In this video, we will look at section 9-2, logarithms and logarithmic functions. Logarithms are really just the inverse of exponential functions. So let b and x be positive numbers with b not equal to 1. The logarithm of x with base b is denoted log base b of x is defined as the exponent y that makes the equation b to the y is equal to x true. So suppose b is greater than 0, not equal to 1. For x greater than 0, there is a number y such that log base b of x equals y if and only if b to the y is equal to x. So we can just follow that simple area of where everything lines up. So the base becomes the base. The answer of the logarithm is the exponent, and the number of the logarithm is the answer of the exponential. So all we have to do is line it up. So we have our b here, so we're going to write each equation in exponential form. Log base 8 of 1 is equal to 0. So 8 to the answer is equal to the x. So, and if you plug in your calculator, 8 to the 0 power is equal to 1, and anything to the 0 power is equal to 1, so we know that is correct. So we do the same thing here. Okay, so we got the base, so we got log base 2 of 1/16 is equal to -4. So 2 to the -4 is equal to 1/16. And there we go. Okay, so that's what we're looking at doing. But now we also need to be able to go the other way. So write each equation in logarithmic form. So this one just goes backwards. So we're going to start with 10 to the third is equal to 1,000. So we have log, and now we just work the other way. So if you're looking at that little diagram, it just becomes log base 10, so we got the base again, of, now it's just reversing your thinking, of the answer is equal to the exponent. And if you have a calculator capable of doing log base 10 of 1,000, hit enter and you should get 3. Okay, so let's do another one. So again, it's the same thing. Follow the exact same routine. So we have our 1/2, we have our answer, and we have our base. So our base, there we go. So all I'm going to do is write them in their appropriate spots. So log base 9 of our answer is equal to our exponent. Okay, so just following that illustration will get you to where you need to be. So now, just evaluate. Log base 3 of 81. Now again, it's the same thing. We can reset this into a situation where we say 3. Now if we could say it's equal to y, so 3 to the y is equal to 81. And now 81 we can rewrite 81 as 3 to the 4th power. And now our property of exponents like this, we can say y is just equal to 3 because the bases are, or excuse me, not 3, sorry about that. Y equals 4 because the bases are both 3. Okay, so I'm not changing any rules, I'm just applying different ones. Okay, I'm just applying an old rule. So same thing, log base 4 of 256. So I can say equals, I'm going to say x this time. So now I have 4 to the x is equal to 256. And I can write 256 as 4 to the 4th. So again, using my rules of exponents, I can just say x is equal to 4. And there we go. Okay, so now we're going to solve each equation. Okay, and again, now this is exactly what we just did, except now it's just reversed. So I have the base, so log base 9 of x is equal to 3 over 2. So the base to the answer is equal to the number. All right. So now all I'm going to do is I'm just going to grab a calculator, and I find out I get 27 is equal to x. And that's all. I mean, that's all there is to it. Okay, I'm just rewriting it using those properties. So log base 16 of x is equal to 5 over 2. So again, I'm just going to rewrite it. So 16 to the 5 over 2 is equal to x. Just plug it into your calculator, and you end up getting 1024 is equal to x. Okay, so again, it comes down to properties. Follow that illustration. So now another one, logarithmic to exponential inequalities. So if b is greater than 1 and x is greater than 0, then log base b of x is greater than y, then x is greater than b to the y. And conversely, same thing, log base b of x is less than y, then 0 is less than x, which is less than b to the y. Okay, so all we're going to do here is, again, follow what we have. Okay, so depending on what inequality you have, depends on how you flip it. So log base 4 of x is greater than 3. So since I'm looking at a greater than symbol, I need to go to x to the b. So I just have to rewrite it. So x is greater than 4 to the third. And so in this case, we end up just saying x is greater than 64. And that's all there is to it. So like I said, all I did was transfer the information up top down to rewriting the equation, the logarithm. So now log base 2 of x is less than 4. So now I'm working with a less than symbol. So that means I'm going to write it like this. So 0 is less than x, which is less than 2 to the fourth. And now I just simplify, and I get 0 is less than x, which is less than 16. And there we go. Okay. Next one. If b is a positive number other than 1, then log base b of x is equal to log base b of y, if and only if x is equal to y. So, just like properties of our exponentials, if the bases are the same, then the exponents were equal to each other. Same thing with logarithm. If the base is the same, the inside part is the same, is equal to each other. So log base 5 of p squared minus 2 is equal to log base 5 of p. Then check your solution. So I'm just going to set it up. P squared minus 2 is equal to p because the bases, they're both log base 5. So I'm going to subtract p from both sides because I have quadratic, so I'm going to solve. So I have p squared minus p minus 2 is equal to 0. All right, so now this can factor out. So I have p minus 2 times p plus 1 is equal to 0. Solving both, set these both equal to 0. So I get p is equal to 2 and p is equal to negative 1. Okay. So now we got, like I said, it says check. So I'm going to check both of these. So I'm going to put them back into the original. Log base 5 of 2 squared minus 2 is equal to log base 5 of 2. And so here I simplify, I get log base 5 of 4, that's just 4. 4 minus 2, so log base 2 of 2 is equal to log base 5 of 2. So it works out, so check. Now we gotta do the other one. And right away, before I even do any work, this is what's great. So if I get log base 5 of negative 1 squared minus 2 equals log base 5 of negative 1. Right there. You cannot put a negative into a logarithm. Okay. into a log. So that one does not work. Okay, so -1 does not work, so your only answer in this case is p is equal to 2. Okay, so if a number makes a situation where it's a negative put into a logarithm, it cannot work. Okay, next one. Last one. If b is greater than 1, then log base b of x is greater than log base b of y, if and only if x is greater than y. And log base b of x is less than log base b of y, if and only if x is less than y. So it's the same thing with an equal sign. Just if the log bases are the same, then they're set equal to each other. Okay? Or in this case, inequality to each other. So log base 10 of 3x minus 4 is less than log base 10 of x plus 6. So now all we're going to do is follow the inequality. So I get 3x minus 4 is less than x plus 6. And we're just going to plug them in. All right, so we get, so we're going to subtract x from both sides, add 4. So I have 2x is less than 10, so divide by 2, so x is less than 5. So x will have to be less than 5, but now keep in mind that for this one, x cannot equal or cannot be less than 6. Okay, or it cannot be -6. All right, so it must be greater. So that still works, okay, because all the way down to -5.9, it still works. You still get a positive number. But this one, if we're less than, think of that, 3x minus 4 is equal to 0, add 4 to both sides, 3x is equal to 4. Now let's just say less than. Let's not say equal to. Let's say less than, because if it's less than 0, it becomes negative, and we can't have that. So then I'm going to divide by 3. So x, if x is less than 4/3, okay, if it's less than 4/3, it won't work. So it has to be more. Has to be more than 0. So if it's less than 4/3, it will be less than 0, it'll be a negative number. So that tells me my x has to be greater than 4/3, and it has to be less than 5 for the solution to be true. Okay, so I know there's a lot of new rules and a lot of things to keep in mind, but go slow, take your time, follow the little charts.